So despite the fact that we added um, a new class to the code, that we, added all the required functions and so forth and so forth, if you see under the hood, it is still just a combination of variables and functions. This is just because this is how hardware works. Hardware recognizes variables as objects in memory, and hardware recognizes, your CPU recognizes callable functions. You can make a call at a certain address, the function begins to execute, and eventually it finishes its execution, and you move on to other functions to execute, right? So the building blocks really are variables and functions. However, we just recognize that sometimes it's very convenient to repackage member variables or repackage variables and functions as a single concept under one umbrella. And we call it, generally speaking, a class. And I told you that we can also use struct, right? But right now, let's just focus on a class definition. Struct and class is the same thing, and later on, I will give you some examples where there are some advantages of using one or the other. The textbook is also covering this topic pretty well. Okay, so back to this presentation. So here we say that bringing together some functions and variables, like we did over here, actually over here, right, is a new concept for us, and this, generally speaking, defines new C++ user-defined type. User-defined type. And this is what comes together as, if we did this in just one file, this is how it would look like. And here I'm using like a birthday variable instead of the variable that I use, just date over here. And the next stage, of course, is that we want to be able to improve this concept of the date and to make it more useful. Implementation of the class in this specific presentation is delegating all the work to these functions. Remember that because we already have a library of functions which do pretty good computations of serial dates and conversion to and from serial date, it just makes sense to base the concept of the date on a single integer that is representing serial date, right? So in our class, we never store, right here, we don't store month, day, and year. We store a single integer which represents all of them together. Okay, so that's the idea. It's often the case that you want to, if there is already a library of existing functions, like for instance, C++ standard library of math functions, other types of functions, like for instance, using collections and algorithms, you just simply delegate all the work to existing library while building your own concepts. It's typically something that you do in parallel all the time. Now, this is something I've covered a little bit 3 weeks ago, and we gave an example of it, but we'll do it again today. Is that if we want to be able to essentially use date with cout directly, instead of having to do this tedious get month, get day, and get year, it would actually be quite nice to do something like this. Just this, right? Just send date to cout. And I'll just use a space between the two versions of it, right? So would be nice to actually let me demonstrate it on a separate statement. Basically, what I want to do is I want to be able to do this directly. Okay? And this brings us to the idea that when you have one object, cout character output is an object inside the standard library. It is created for us inside this IO stream when we include it, and it's available in any application. And date is our own object. So we have two objects, one type of object and another type of object. If you want to be able to establish communication between the two of them using some sort of operator, which is just a fancy way of replacing a function, you have to define a function like this. I will copy it from this presentation, but now I'm going to be jumping to definition of our class. And I say that once we have this class in place, it's been declared here and becomes available to the compiler. The next thing that I can do, I can add this operator, and I'll just define it fully like this. And I'll add this declaration, and I will probably also make it a constant reference. We've been covering references also 3 weeks ago, right? So I will add this declaration of a function named operator shift. It's called left bitwise shift operator. But we want to be able to use this operator to communicate between our object and object cout. Notice that this is technically speaking, this is an overloaded operator. Okay, this is what this thing is. If you want to be able to do it conventionally like this, you have to provide your own operator. Operator overloading is a separate topic, but just a quick example here to make our dates more convenient for debugging and displaying them. So step number one, open the header file where the class declaration originally was created and add this overloaded operator declaration. And then copy it over to the implementation file for our class. And just scroll down, copy and paste, immediately replace the semicolon with the actual implementation, right? And inside this implementation, what we're going to do is we're going to steal the statement from here, the whole statement, copy and paste it over here, right? So I don't need new line. I will use the / as delimiters. And here the parameter is called dt, so I'll just switch that to dt. Because that's the parameter. It should do the work. And you see that this operator provides just a formality between cout and our date. And by the way, and here, of course, let me see, this is output stream. OSTR, and I will replace it by OSTR and OSTR like this. I just make these adjustments as I move, and then I also need to be able to return it back to provide some continuity for output statements. Well, anyway, so this is how you see this. Just like I said, this is just a formality that basically when the compiler will see cout combined with the date, and there is this operator being used, what it's going to do is it's going to look up if we have provided an operator like this, and we just did provide it, and it will match the type of this object with the type of the parameter that was passed in. It's being passed by a reference right here because we don't want to duplicate cout. It's not a good idea to make a copy of it. That's why we pass it by reference using the ampersand with our parameter type, and also passing the date that we have by constant reference because we don't change it. And the compiler will find that this this and this matches this specific overloaded operator. And of course, what it does is takes the output stream object and uses already overloaded operator for integer, 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 and character right here, and another character right here. So everything should work just fine. Let me comment out the original version. And now I just replaced it by the new version of this output statement, which just simply takes the object and says, okay, uh, let's just send it to character output device. Let's try building this and see if it works. Oh, I got a whole bunch of errors. Let me see what's OStream is not a member of STD. 1 second. We'll fix it.